To calculate the equilibrium constant, you have to take the information given to you in a chemical reaction and then plug it into this equation right here. So in this equation right here, we have a capital A, B, C, and D. And so the capital letters stand for the chemicals involved, and then the lowercase letters, the lowercase a, b, c, and d, stand for the coefficients. And so notice here that what we have here is the chemicals involved, and then we have the coefficients going before them. So then when we plug them into this equation to find the equilibrium constant, the coefficients are translated into becoming exponents. And so we're not copying the chemicals over here into this equation. What we're doing is we're taking the concentration expressed in terms of molarity, and we're plugging that into this equation. So as you probably have already figured out, this right here stands for equilibrium constant. So we can say that an equilibrium constant is based on concentrations, and there are other gases based on partial pressures. But this is based on concentrations. And so I'm going to go ahead and jump into this example right here. And so we have this equation right here with hydrogen and iodine creating hydrogen iodide. And so notice here that what's on the left side of the equation goes in the denominator of the equation. So we have what's on the left side of the equation going into the denominator, copied over with the subscripts. But since they only had a coefficient of 1, we don't use those as exponents. Now with hydrogen iodide, it's on the right side of the equation. And notice up here, the chemicals on the right side went in the numerator of the fraction. So we have it over here in the numerator of the fraction, and since there's a coefficient of 2, it has an exponent of 2. So now we go ahead and we take a look at the molarity of each chemical, because the concentrations here must be expressed in terms of molarity. So the molarity for H2 is 1.0 times 10 to the negative 3. It's the same for iodine too. And then for hydrogen iodide, it's 7.4 times 10 to the negative third. So now we just need to plug this in to an equation. And so what we do is we're just going to follow this setup right here. So we're going to take that number, and plug it in with an exponent of 2, and then just put that over the numbers that are over here. And so we can go ahead and reduce this. And so after we square this, it becomes 5.48 times 10 to the negative fifth. And then after we multiply these numbers together, we get 1.0 times 10 to the negative sixth. And so then just finishing out that equation, we get an answer of 54.8. And notice there's no units here. Earlier we had units of molarity. But now there's no units, and that's because the equilibrium constant is expressed as a unitless number. And that's because when you plug this into an equation, when you plug the equilibrium constant in there, it doesn't need a unit. And you'll understand that better if you plug this into an equation. You'll realize the units work out without the equilibrium constant having a unit. One last thing to note and to remember is that you only need to know the concentrations of the reactants and products to find the equilibrium constant. You do not need to know the reaction mechanism.